pen and paper so that we can go ahead and get started. And then we're going to take it from there, okay? So those of you all that are here tonight, my name is Professor TK the Chemist, and I actually do teach chemistry, and I've been teaching chemistry for a very long time. So if you got chemistry questions, as long as they are General Chemistry 1, I can help you. And General Chemistry 2 students, you guys will be on board tonight at 8:30. So we're going to be on here for a while, giving you guys the information that you need. So what I want you guys to also keep in mind is that no question is a silly question, is the one that you don't ask. So make sure that if you are confused about anything that you want to know, that you ask me in the comment box, and I'll do my best to answer your questions, okay? So what we've got today, and by the way, let me go ahead and change this schedule so you all can see the times also, since we're here tonight. It's 7 p.m. to 8:15, and then from 8:30, from 8:30 p.m. till 9:30, that's when I do my live for my evening students. So as you guys are coming through, make sure you all grab a pen and paper, because we're going to take some notes tonight, specifically on writing chemical formulas. And also, guys, as you're coming in, make sure you tap that screen, because that's going to help us send this analytics out, to let everybody know that Professor TK the Chemist is here. So I don't want anything else other than a tap, okay? That's all I want you all to do, is just send me a tap, because that's going to send out the notifications to everyone that we are live here tonight, okay? So for General Chemistry 1 students, we're going to learn how to write chemical formulas. I know that so many students struggle with this to the point where they don't know if they're coming or going, right? So this is what I'm going to do. I'm going to actually walk you all through writing out these chemical formulas. And as we practice them, I'm going to give you some rules. Now, I just posted a video, a funny video, just to kind of help you guys remember this stuff right here, okay? And this is some of the things I actually wrote out today, earlier when I went live at 10 a.m. So what we've got here are cations and anions, okay? If anything is positively charged, they are cations. If they are negatively charged, then they're anions. And so when you actually do the swapping, this is where you get to what's called an ionic compound. Guys, you do not have to make this difficult at all, okay? I promise you, you don't. So we're going to get into writing out these formulas here. And as you all can see, I'm going to remind you of those charges, because I know that several of you may not have a periodic table on standby, but I'm going to actually help you remember them, okay? So when it comes to writing out the chemical formula, for instance, when you have an ionic compound, it's between a metal and a non-metal element, okay? They will swap charges, and they will have an IDE ending, okay? So this is something that you guys need to know. In order to write out an ionic compound, you have to remember that it's between a metal and a non-metal. So I'm going to color code this, okay? So you all can see this. A metal is going to be in yellow, and a non-metal element is going to be in green, okay? So that way you all can see that if they are opposites, then that means they're going to swap charges. Hello, for sure, 27. Good evening. Good evening. All right. So what I'm going to have you all do is we're going to walk through these together, right? If there's any that you are unsure of, make sure that you tell me to slow down and let's go back. What's going on? How you doing? All right. So let's start with the first one, and make sure that you guys tap the screen, because all that's going to do is send out to the TikTok world that Professor TK the Chemist is here, and that we need some more students to come on in the building, okay? All right. So now, what I have for you all here is the first compound, all right? And this is sodium chloride. Now, what you have to remember, let me wipe off right here. what you have to remember is that this formula here for sodium chloride, you know that sodium has a +1 charge, and chlorine, which becomes chloride, when it becomes a formula, it has a -1 charge. The two ones are going to cancel out because they are the same, so you end up with the formula of NaCl. It's that simple, okay? It is that simple. Now, let's keep it going. All right, let's keep it going. Now, again, I'm going to assume that you all have a periodic table on standby, but if not, you can always use the one that I have right here on the screen, okay? You can always use the one that I have right here on the screen. So let's take a look at the next one. You've got magnesium bromide. All right, magnesium bromide. Again, whenever you have ionic compounds, all you are doing, guys, is swapping the charges. Now, magnesium has a +2 charge. Bromine has a -1 charge. So they're going to swap. Magnesium is going to pick up the 1. Magnesium is going to pick up the 1, and the 1 is understood. So we don't have to write the 1 in. Bromine is going to pick up the 2, but we will write the 2 as a subscript, and that's the formula, MgBr2. That's right, crisscross, applesauce. That's right. You crisscross the charges. Okay, again, we're going to keep on going because we've got plenty of examples that we can follow, all right? Plenty of examples. What do you mean, what setup am I using? All right. So now, if you look at the next part, you've got calcium fluoride, right? Calcium has a +2 charge. Fluoride has a -1 charge. You guys know what to do. Swap. So calcium's going to take the 1, but the 1 is understood. And then fluorine is going to take the 2. And you just write that as a subscript. I don't have an iPad. This is I'm writing on this little thing right here. It's called a Wacom, WACOM, a Wacom pad. This is for General Chemistry 1. All right. So far, are there any questions? If not, we're going to keep it going. Okay, now let's take a look, excuse me, at the next example right here. Potassium oxide, right? Congratulations, Ilias or Ilis. Congratulations. Wait, how do we know to keep it in the subscripts? Well, whenever you are writing out a formula, you always write the numbers as subscripts. Like, for instance, if I tell you to write the formula for water, you say H2O, but you never write it as a superscript, okay? You always write formulas as subscripts in chemistry. Oh, that's okay. So if you've got potassium right here and oxygen, I know that potassium has a +2 charge. Oops, sorry. Oh, no, it does not. It has a +1 charge. My bad. Oxygen has a -2 charge. You guys already know what to do, right? You're going to swap those charges. So potassium is going to take the 2. So you're going to end up with K2, and then oxygen is going to take the 1. Now, again, the 1 is understood, okay? Hey, we are doing kinetics for General Chem 2 at 8:30. Yes, so General Chemistry 2 students will come in at 8:30. This is for General Chemistry 1 students. Okay, so if you are in here tonight for General Chemistry 1, you are in the right building. If you're here for the TEAS 7 chemistry portion of the exam and you need review with that, you are in the right class. However, if you need help for General Chemistry 2, that will start at 8:30. Okay, 8:30. Now, let's go ahead and go to the next example right here, okay? Here's what I want you all to keep in mind, that as you go through these practice problems, all you need to do is refer to a periodic table. So let me explain to you all why I say that. Some of you all are probably wondering, where is she getting these charges from? Where is she getting these numbers from? So Monday through Thursday in the morning at 11:30 a.m. Eastern Standard Time, and in the evening, okay, at 8:30 p.m. Now, what I want you guys to do, I'm going to zoom out a little so you all can see this, but I had already pre-written out these charges. All the elements that are positively charged are most of the time metals. So right here, group 1, group 2, groups 13 and 14, those are metals. Therefore, they have a positive charge. When you get to groups 15, 16, and 17, the charge becomes negative, and those are called anions. Nonmetals are anions. Positive charges are metals called cations. Now, when you combine those two together, they're going to swap. You're welcome. They're going to swap charges. So that's where I'm getting those from. All right. So back over here, when I was asking you guys to write the formula out for aluminum sulfide, okay, for aluminum sulfide, again, I'm going to assume that you all have a periodic table on standby, but if not, I'm giving you all the charges automatically so that you're able to follow along with me, okay? So that you're able to follow along with me. But let me just show you all how I'm getting these charges, okay? So again, aluminum is right here, okay? So just FYI, and I'm going to zoom in so you all can see that. See that? Aluminum is in group 13 with a +3 charge. Sulfur is in group 16 with a -2 charge. All right. And thank you guys so much for sharing the live out. And also all the follows. I appreciate you guys. Because look, for those of you all that are new to me, I am a chemistry professor. So this is my love is helping students that need help. All right. So for what we're doing tonight, if you all have questions, make sure that you jump in and let me know. All right. So now for this one, aluminum sulfide. Yep. All you're going to do is swap those charges, Al2S3. See how simple this is, guys? It is simple. Hey, Lola, future RN, you started your chem class today and you're so stressed because you didn't understand anything. Well, honey, come on and follow me. Make sure that you chime in every day if you have to, okay? So the fact that you just started chemistry, is this an accelerated class as to why it's just now starting in February? Is this an 8-week class, a quarter class? How's your class set up? We're writing chemical formulas, G. Yes, we're writing chemical formulas. We're learning how to write formulas. So when you look on the back of your food label, you'll be able to identify what that formula is made of. If you are going into nursing, they'll see these in medicine class, in their pharmacy classes. All right. Oh, got you. College starts in February in California. Okay, got you. You're welcome. Okay. You're switching charges because these are ionic. Okay. For those of you that are asking certain questions, if you have not had chemistry yet, I need you to hold tight, okay? Hold tight for a minute, okay? Because whenever you guys come in, I am going to be under the guise that you are currently in chemistry, so you know a lot of what we're doing and you just need some reinforcement, okay? So when you look at these questions right here, for right now, we are only dealing with ionic compounds. Ionic compounds are based upon metal and non-metal elements that are coming together. So right here, these are the notes that I wrote down. When you have a metal and a non-metal element, they're swapping charges and they have an IDE ending, okay? And it's okay if you had to take OChem twice, because honey, me and OChem did not get along and I was in that same boat, okay? So it's okay. Chemistry is one of those classes that if you don't understand it the first time, it may take 2 times to go through it in order for you to comprehend. And that's okay. That is okay. The best of us have had to do that, okay? Now, I want you all to take a look at this next example right here. Lithium nitride, okay? Lithium nitride. Again, I always teach this way to my students because you know what? We don't want to have all those extra over explanations just to say swapping the charges. So for lithium, lithium has a +1 charge. Nitrogen has a -3 charge. So what you're going to do is swap them. All right. Lithium again is going to take the 3. And by the way, do not worry about the positive or negative. That will come into play later on down the road in like towards the end of the semester. But for right now, all we are doing is just simply writing our charges out so that we can just swap them. So don't worry about the positive or negative sign. Okay? Do not worry about the positives or negatives. Seeing you said you hated chemistry in high school, but now you're studying chemical engineering. So if you hated it in high school, what made you want to study it in college? Because usually if you don't like it, you wouldn't want to go through with it again. All right. Now, yes, chemistry. Okay, I'm just going to say this. It is one of those classes, like your math classes, that you have to do every day. When you're taking the class during the semester, 16 weeks, you should be studying 6 to 9 hours a week in that one chemistry class. All right, bio pre-med. So you know, you're in biochemistry. Yes. Ionic. Yes, you got to study. You guys know you've got to study. Thank you. Listen. Okay, I understand. Thank you, Missy, for the puff. But you know what, guys? The thing you all have to keep in mind is that a lot of the classes that you take depends on the professor that you have. If you have a professor, no disrespect to any of the professors that are from other countries, because trust and believe, when I was in college, 80% of my professors were from other countries, and they had thick accents, thick dialects. Most of your STEM professors will come from other countries because they know their sugar honey iced tea. And because they know their material, they're the ones that oftentimes teach those classes. But as a student, you have to bring in a tape recorder or something to record them so that you're able to play their lessons back in slow motion because they get excited and they talk really fast and their accents are hard to decipher. But it's doable, okay? Yes. So I get it. I know. I've been there, done that, and got the degrees behind some of our best professors are from other countries, but then I also became a professor. And so I get it. That's why I go in slow motion because I'm a Southern girl. And I know sometimes, I may have students that come from New York or from the West Coast. So accents are just that, but you can get through it. Speaking of getting through it, let's look at barium iodide, okay? Yes, see, yes, my math teachers, yep, my calculus teachers, yes, from another country, but they knew their stuff and they had the patience of Job. But at the same time, when I was young and didn't want to deal with it, but you know what? I got through with it. Okay, New York. Okay, New York in the building. So if we look at this next question right here, barium iodide, you've got barium with a 1. Remember, do not worry about the positive or negative. Just swap the number itself, okay? And then you're going to take the I, and it's going to pick up the 2. Now, y'all see how easy this is, right? You're just swapping charges. Ow, what you talking about? What are you talking about? Okay. Okay, now Mitzi, if you're taking chemistry this summer, the same for students who are taking chemistry on a quarter system where it's like an 8-week course, you're going to have to do double the studying because during the summertime, it's faster paced. Well, I'm just saying it's faster paced. But you come on back and make sure you follow me so that way you can pick up what we're putting down. Now, for those of you that are just stepping in, we just talked about ionic compounds where you're swapping the charges. But suppose you get those charges that are what we call transition metals, where you see a Roman numeral. Now, guys, the first couple that we did y'all see Roman numerals? No, we were not dealing with Roman numerals. But guess what? In these next examples here, we're going to deal with Roman numerals, and those Roman numerals are going to do what? It still holds the same, but Roman numerals tells you what element has what charge. So iron has a +3 charge because check this out, guys. Iron actually has more than one charge. Yeah, we're doing that right now. We're naming them right now. So let me tell you this much. On my study handout here, these are the charges right here. You see this for iron? +2, +3. They are identified in Roman numerals. And if you want a shameless plug, if you want to get a copy of that, it's a formula mat. It's size 11 by 17. It has all of your main formulas that you'll have to know for General Chem 1. I put at least 85% of them on this. It's front and back. Okay? So what you're going to do right here, you're going to look at chloride, okay, which has a -1 charge, and then just swap. Again, iron takes on the 1 and chlorine takes on the 3. And there's your formula. So if you put FeCl3, that is your answer. Yes, it is upstairs. To get that formula mat. Okay, so whenever you all are taking your test, let's say that you forgot the rules for the periodic table, the trends of the periodic table. This has all the answers on there, from the atomic radius to the ionization energy to electronegativity. How do you say the formulas? How do you know what the formulas are? Okay, how do you know what the charges are? All of that's on here. Same thing with the metric system. Okay. Yes, you know what? Memorizing them is good, okay, because it does save you some time. Okay. Thank you for your heart, me team mistress. Mysterious, yes. Oh, yes. And you know what, General Chem 2, I will be actually teaching General Chem 2 tonight at 8:30. So from 7 to 8:15, I am doing General Chemistry 1. And then from 8:30 to 9:30, General Chemistry 2. All right? Okay, now check this one out. Number 12, we've got iron Roman numeral 2 chloride. All right, so I'm going to show you all the difference. Iron Roman numeral 2 has, again, the charge of Roman numeral 2. All you're going to do is swap the charges, okay? FeCl2. Take a look right here. See the difference? FeCl3 was for iron Roman numeral 3 chloride. FeCl2 was iron Roman numeral 2 chloride. Okay? So listen, don't overthink it. And guys, I just posted a video on this, so y'all can go ahead and like it. Go out, like that video that I just posted where I'm showing you the rules. I actually put the rules up, okay? So that way you'll know if we're dealing with metal and nonmetals, ionic compounds, you swap the charges. The ending is IDE. Yes, magnolias and mythos. Yes, when it's a Roman numeral, we always assume it's a positive charge. Absolutely. And here's why. Those Roman numerals are found right here. You see how I highlighted them? And this is just some of them, not all of them. And what I did right here was majority of the periodic table, I would say 85% of the periodic table are metals. And because they're metals, they are positively charged, called cations. Those that are negatively charged, those are your nonmetals, and those are called anions. Okay? Anions. Okay. So yes, everything that we're doing here for right now so far has just been to swap the charges. And that same rule applies to those Roman numerals right here, okay? So let me give you another example, okay? I'm going to give you another one. Let's look at, we're going to skip 13 for right now because that deals with the polyatomic ion. And so just wait until we get back to that part before we actually talk about the polyatomic ion ones, okay? So we're going to come back to that one in a minute, all right? So I'm going to display these two examples right here so that you all can see how these two are similar, okay? You're going to see how they're similar. Right here, you've got lead, Roman numeral 4, oxide. Those are the charges. Roman numeral 4 tells you a positive 4 charge. Again, swap them. Lead picks up the 2. Oxygen picks up the 4. But in chemistry, we actually will reduce both of them, both of these elements, by dividing it by 2 to get the final formula as PbO2. But if you did not do that, I mean, it's still right. However, your teachers may be looking for PbO2 as the answer for lead for iodide. I'm sorry, listen to me, oxide, okay? Lead for oxide. Now, but again, either answer would be fine, but it depends on what your teachers would prefer you to have. 90% of them will want the one that's here, okay? Now, check this one out. If I write lead 2 oxide, watch this. Lead, Roman numeral 2, oxide, means that the 2 2's have canceled out. And so therefore your answer here is PbO. Now, what I want you all to know is that in chemistry, if you wrote it as Pb2O2, most of your chemistry classes, 99% of the time, they will prefer this as your answer because the 2's have canceled out. When they are the same, they cancel out. Okay? They cancel out. So keep that in mind. Keep that in mind. Keep that in mind. All right? Now, let's take a look at one more example right here, okay? One more example. And again, all you have to do, okay? All you have to do is just draw a line down the middle, like we've said before, and look at cobalt. Cobalt has a +2 charge. Bromide has a -1 charge. Y'all already know what to do. Cobalt takes the 1, bromide takes the 2. Now, you have to remember how to write the formula out though, okay? You have to know whenever there's a Roman numeral, you have to make that the charge. You have to make that the charge. Previously up here, I did not have Roman numerals, okay? Let me show you the other examples. See, in none of these formulas did we have Roman numerals. But you have to look at your periodic table to find those charges. Only your transition metals, which are those elements found in the middle, plus these other two over here, lead and tin, right here, those are the ones that have more than one charge. Okay? If they have more than one charge, we identify them by saying Roman numerals. Okay? It's that simple. All right. Now, let's talk a little bit about those that have polyatomic ions, okay? And I'm going to come back to these over here that have numerical prefixes. We're going to come back to that one later. But let's go ahead. We're going to skip to this part right here, okay? Those that have polyatomic ions, we need to take a moment to understand these, okay? And when I go through this with you, I'm going to go in slow motion, all right? Slow motion. As Juvenile would say, slow motion for me, okay? Because I know that so many students grapple with this, all right? And if you don't have a grasp of these problems, y'all, it's going to be a madhouse, okay? And I don't want you all to get frustrated. So here's what I'm going to do. Okay, so far. Okay, we're gonna go slow motion. So let me tell you all what this means. Polyatomic ions, and I'm gonna write this up above so that way you all can see. Okay. Okay, here we go. I'm gonna write this note down for you. Whenever you have three or more elements, okay, three or more elements in your formula, you will have an ITE or ATE ending, okay, and you will have to still swap the charges, okay? Now, here's the thing though. Here's the thing. Because you will have to swap those charges, you have to, I always tell my students to use parentheses so that whatever the charge that it acquires, it goes on the outside, all right? It goes on the outside. Now, what you all can do is make flashcards with these polyatomic ions on them so that you don't forget them, okay? Just that simple. So let's go ahead and do this one for a moment. We've got calcium with a +2 charge, right? That's calcium. Now, what is the name for carbonate? All right. Right here. Carbonate is CO3 with a -2 charge. So I'm going to write it out. CO3. I'm going to put parentheses just in case it picks up something else. All right. Well, look at this. The two 2's are going to cancel out. So my formula is going to become CaCO3, and the parentheses drops off. Okay? The parentheses drops off. So now, let me show you another example where it's going to pick up a charge on the outside. So let me do aluminum carbonate, okay? So you all can see what I mean by this, all right? I'm going to do aluminum carbonate, and you'll see what I mean, all right? You will see exactly what I mean. All right, I'm going to do this one right here, okay? So you all can see this. So this is aluminum carbonate, okay? So here's the deal right here. I'm going to still draw my line down the middle, okay? Aluminum is going to be Al with a +3 charge. Carbonate is CO3, still with that -2 charge, right? They're going to still swap. They're going to still swap. So aluminum is going to pick up the 2, and that carbonate ion, it's going to pick up the 3. All right. So watch this. Aluminum, subscript of 2. Carbonate, the entire thing goes in parentheses, and on the outside is the new number, which is that 2. Hey, 3D11, we are going to be doing General Chem 2 at 8:30. I'm glad you're in here and you gave them some word of advice of telling them that they got this. I'm glad you said that. Liz asks, do we always have to include charge numbers for these problems? Yes, you do. Now, when you talk about covalent compounds, you do not, okay? We're going to come back to covalent compounds in a minute. But with covalent compounds, you do not have to worry about charges. This, in fact, deals with just the number of what you have. And I'll explain that to you in a minute. Yep. I'm glad you asked that question, though. That was a really good question. Okay. Now, take a look at this next part of the formula right here. Yeah, oh yeah, 3. I'm glad y'all saw that. I was making sure y'all saw that. Okay, yep, I'm making sure y'all saw that. That's why I put it there, to make sure y'all were paying attention. Okay, and that you were picking up what I was putting down. Yes, it is Al2 in parentheses, CO3, close parentheses, 3. I'm just making sure y'all not sleeping. Okay, just making sure. All right. So y'all saw that. Yes, you're always going to flip it. That's right. Always flipping. Now, take a look at this next one, okay? Potassium nitrate. Okay. Potassium nitrate, again, you're going to draw a line down the middle. And I do that for every one of these problems. Potassium has a +1 charge. Nitrate, anytime you're dealing with your polyatomic ions, I always put in parentheses so that the new number goes on the outside. But in this case right here, the ones are going to cancel out, so your formula becomes KNO3. Okay? That's the formula. You're welcome. That's the formula for potassium nitrate. The parentheses will fall off, so you don't have to write the parentheses because it's not picking up a number greater than 1. Okay? We got more. Oh, this is a good one. This is one of my favorite formulas to write, which, by the way, is found in Pepto-Bismol. So if you got a tummy ache because you ate some spicy stuff and you have acid reflux, you use magnesium hydroxide. But the reason why I love this problem is because so many students get it wrong. And not that I'm picking on you, but because you're not aware, you're not boloing, being on the lookout. All right, you got a bolo. Be on the lookout for the charge that it's going to pop up with. That's going to pick up on the outside of the parentheses. So magnesium is going to pick up the 1. So that's Mg, but the 1 is understood. Hydroxide, OH, that goes in parentheses, and the 2 goes on the outside. However, do you all know so many students will write this as MgOH2? They are not the same. Hey, Bagel, I will actually be going live at 8:30 for General Chem 2. So whatever questions you have for General Chem 2, you make sure you pop on back in here at 8:30. Julia, we are not actually working on Lewis dot diagrams right now. Okay. Whatever the charge is, it goes on the outside. So is the ion always in parentheses? Yes, it goes on the outside. Marbar, I will be going live this week from, matter of fact, let me give you all the schedule so that way you all will know, okay? Right here, Monday through Thursday, I will be here from 10 a.m. to 11:15 a.m. And I need to let you guys know that this is EST, Eastern Standard Time, okay? Yes, on the outside only. On the outside only. If you are doing General Chem 2, then that is at 11:30 a.m. Okay, so those are the times for this week. So those of you all that need some chemistry help, y'all better come find me during that time. Oh, yes. Yes, please do. Yes, I got you for 1 and 2 for chemistry. Is this Jemiah? Okay. Now, let me go back over here where we were. Oh, this is a good one. This is the one that I skipped when I told you all. Okay, good. I'm glad I got your name right, honey. Mm-hmm. Yes, sometimes we do go over the same thing. And because I always have my California students that come through here, I try to make sure that I'm on for my West Coast students in the evening time, even though I got some of y'all that like to get up early. But yes, sometimes I repeat some stuff. And then other nights I may give more problems. Like today, like earlier today, I did not do the polyatomic ions. I'm actually doing that tonight, like right now. So they'll actually go over this part tomorrow. Okay. So now when we look at copper 2 sulfate, we got 2 things going on here. You're welcome, honey. You're welcome. You've got copper with the +2 charge. Then, so see right there, we just talked about those elements that have more than one charge. So copper, Roman numeral 2. I'm telling you what it is, what it's identifying with the charge, +2. Sulfate is SO4. It has a charge of -2. Well, y'all know the deal. When the numbers are the same, they cancel out. So in this case right here, your formula becomes CuSO4. CuSO4. Okay. No, Liz, you will not find sulfate on the periodic table. That's a polyatomic ion. Your polyatomic ions are typically found in your chemistry book or on my formula guide here, where I've given all of my students the charges that are for polyatomics that are mostly the commonly known ones, okay? The ones that are mostly known. So if you look at this chart right here, you can either write them down on index cards or go to your chemistry book or practice, writing them out, because polyatomic ions are not on the periodic table, only individual elements, okay? Only individual elements. No, chameleon team, it's just a personal preference. Some people will write iron with the +2 charge, and then sometimes they'll write Fe2+. It's like tomato, or down south we say soda. In the Midwest they say pop. It just means the same thing. Fizz, carbonation. So that's a good question, though. That's a good question. I like that question. Now, we're going to go ahead and mosey on now to covalent compounds. Now, I just got through talking to you guys about polyatomic ions, right? Let's do a few more of those, because I have a feeling that some of you all are like, wait a minute, I need some more help. So let me do 2 more of the polyatomic ions, okay? The ones, if you see an ATE or an ITE ending, that is a polyatomic ion one, okay? So right here, chromium. Now check this out. This one has a charge of +6. Okay. Sulfate, SO4 with a -2 charge. Okay. Just like that. They're still going to swap. Chromium is going to take the 2. Sulfate is going to take the 6. Now, you can either leave it like this, or you can reduce it by dividing both of them by the smallest number and you end up with CrSO4 3. But you would have to know that this is chromium Roman numeral 6 sulfate. Okay? You would have to be able to recognize that. No different than the one that I did with lead 4 oxide up here. See? This is lead 4 oxide right here. But when you reduce it down, this is the one that you will see the most of. Yes, Liz, sulfate is known as SO4 with a -2 charge. Yes. All right. Let's do this last one in this example here with the polyatomic ion before I show you guys the covalent compound one, okay? Which is even, to me, it's even easier, okay? Nickel 2 phosphate. Nickel has a Roman numeral 2, therefore it has a +2 charge. Yes, Andrea, you know the charge by the Roman numeral only for those that are considered to be your transition metals. Transition metals are the only ones that has that charge, okay? The only ones that have that charge. What you have to remember is that if it's not part of that, you do not write Roman numeral. Like some students will write Roman numeral for aluminum. If I gave you aluminum phosphate, for instance, do you see a Roman numeral in here? Absolutely not. So don't write Roman numerals for something that doesn't include it. Roman numerals are typically found with the elements in the middle of the periodic table. So the ones that you see highlighted here, okay? Oh, good. I'm glad you're learning this right now. The ones that you see right here, plus some more, okay? Plus some more. Like gold. Gold has more than one charge. I should have highlighted that one too, okay? So the ones that you see highlighted in the middle, plus these two, those are the ones that have more than one charge. Nickel has more than one charge. Copper has more than one charge. Iron has more than one charge. Gold has more than one charge. Okay? Okay. And that's how you figure it out. Now, where were we? Let's see. Oh, nickel 2 phosphate. So right here, phosphate is PO4 because there's also a phosphite, but we're saying phosphate. Phosphate is PO4 with a -3 charge, okay? PO4 with a -3 charge. Y'all already know what to do. Swap those charges. Nickel is going to get the 3, okay? So you're going to end up with Ni subscript of 3, and phosphate is going to get that 2, PO4, and on the outside 2. See that? Just like that. When I move, you move. Just like that. Okay? So when the charges swap, just put the new number on the outside. All right. Thank you guys so much for the shares, the follows, and the likes. For those of you all that are new here, my name is Professor TK the Chemist. I am a chemistry professor by day and in the afternoon and at night. I give back by giving tutorials online. I also do other things to help students by making study tools and study guides, things that I feel can get rid of all the extra stuff and just get right down to the parts that you want to know. So I try to make it easier for my students. Oh, good question, Andrea. You own it, honey. You asked, but why don't you put the 2 up top? Oh, good question. Okay, here we go. Let me explain it. Let me take you through there. Okay? Let me take you through there. Whenever you put the charge at the top like this, that tells you it's an ionic charge. When you write them as subscripts like this that I'm highlighting in green, that's when you are doing what? Writing it as a formula. Okay? Writing it as a formula. So if I said, what is the ionic charge? You will see it written like this as a superscript. This is telling you the ionic charge of that. But when you write it as a subscript, that's in a formula. Marcos, what it look like we talking about? We're talking about, this is for General Chemistry 1 students, okay? We're doing General Chemistry 1. We're at the very beginning. General Chemistry 2, we're going to be dealing with kinetics. Yes, I'll do another example. Yes, if you do more than one practice problem, it will make sense. Exactly. Exactly. So, let's do another one. Let's do another one. We can do this one. But aluminum phosphate. Okay. Aluminum phosphate, aluminum plus 3. Phosphate is PO4, -3. Which, by the way, phosphoric acid, but we're not going to get into acids right now. But phosphoric acid is actually found in Pepsi. And it is known for being in battery acid. Okay? Anywho, those threes are going to cancel out, and you're going to end up with the formula of Alpo. Okay? Alpo with the 4. Yep, the 3s cancel. Oh, you can get up out of here, Blake. Woo. You know what? It's always 1. Always 1. No, Kay, I do not do organic chemistry, but I do have a pinned post of people that actually have that actually do organic chemistry. Yep. Dr. Andrew Sanchez goes live in the evening times, I think around 8:30 or so. And he actually does, he's from the West Coast, by the way. He actually does organic chemistry. Okay, why don't I put in parentheses? Because the 3s canceled out. So you don't have to put the 4 there. Yep. The 3s canceled out. What kind of precipitation reactions are you looking for, Marcos? What class are you or what unit are you looking for? Yes, Kay, if you go check those people out, and there's another young lady that's dealing with dang, what is her name? Kim with Ken. Matter of fact, this is her right here. Kim with Ken. She actually does organic chemistry. TikTok addict. We're not getting ready to go there. Okay. You're welcome, Kay. Now, that's above everybody's thought processes. Okay, right now, the Boltzmann's equation does not have anything to do with what we're talking about right now. That's like a thermo P-Chem type question. P-Chem, by the way, guys, is physical chemistry. More than likely, none of you all will have to take it. Okay. We're going to keep it moving. All right. Now, for Covalent compounds. Let me tell you all how this works. Covalent compounds are those elements where you have nonmetal plus nonmetal, okay? Covalent compounds are nonmetal plus nonmetal. Matter of fact, let me write this down so you all can see. Nonmetal plus nonmetal. They do not swap charges, okay? They do not swap charges. So let me put this here. Do not swap charges. Instead, you're going to use the numerical prefixes like mono, di, tri, tetra, penta, hepta, hexa. And they still have an IDE ending, okay? They still have the IDE ending. So here we go. Like, for instance, if we inhale and exhale, we're inhaling oxygen, but we're exhaling carbon dioxide, right? Notice I said carbon dioxide. C, di is 2, oxide is O. But when you rewrite that, that's O2, and then you bring the C down. That's the formula for carbon dioxide. You have to know these right here, these numerical prefixes. Mono is 1, di is 2, tri is 3, tetra is 4, and so forth. Okay? So let me show you another one. Sulfur. Sulfur hexafluoride. Again, there's no point in drawing the line because you're not swapping charges. Sulfur is S. Hexa. Hexa numerical prefix is 6. Fluoride is F. You rewrite this as F6 and bring the S down and you get SF6. These are easier because you are writing literally the way that you see the formula being called, okay? You're literally writing them out the way that you see them being called. So let's do this next one right here. Dinitrogen tetraoxide. So by the way, I'll write the prefixes here. Mono, 1, di, 2, tri, 3, tetra, 4, penta, 5. Okay, these are just some of the common ones right here. Okay, di, 2, nitrogen, N. Rewrite that as N2. Tetra is 4. Oxide is O. Rewrite that as O4. And by the way, thank you guys so much for the reshares, the reposts, the shares, the likes, the follows. I appreciate you guys. Thank you all so much. What you have to remember too, in writing these names out, when you have two vowels beside each other, you'll notice that the A went away. So that's why I put tetroxide and not tetra, with the A. A little side note. It's not wrong. And it's, it's almost like a personal preference. Tetraoxide versus tetroxide, like that. Yes, Andrea, yes. So for General Chem 1, hey, Sheebs or Shebs, this is my schedule for this week, guys. So make sure that you're following me. I do have study guides. If some of you all need this for the TEAS exam, for the MCAT, I have a lot of resources on my website. So if you all are interested in that, by all means go. And I got a lot of free stuff on my website, okay? A lot of free stuff. Hey, La Major, how are you? All right. So let's wrap this up because I know I'm going to get prepared for General Chem 2 students, okay? I will do a few more of these. Oh, look, so that y'all don't see the answer. Okay, so that you don't see the answer. Okay, I don't know if y'all saw it. Yes, Monday through Thursday. Yep, Team Mysterious, 7 to 8:15. Yes. All right. So let's do this one. Okay, we're going to close out with this one. You've got phosphorus pentachloride. All right. So again, there's no point in doing this, but if you want to just draw the line, you can. Penta is 5, chloride is Cl, but you rewrite that as Cl5 and bring that P down. And there you have it, PCl5. Okay. Now let me go through another one really quickly right here. Let's see. Okay. I made the screen a little bit bigger, and I'm gonna see if you all can do these last three that we're gonna do right here. These last three right here. Okay. We're gonna do these last three as I prepare for General Chem 2 students. All right. I need number 35. I'm gonna see if y'all can figure out the formula for number 35. Yes, Andre, you know what I'm going to start doing also? Like when I have a few minutes left over during my lives, I will go over some other questions outside of what my plan already is. For Lewis structures, we'll go through Lewis structures next week. Yes, Lewis structures is next week. Okay. So dihydrogen monoxide, look at that. 2. Hydrogen. You rewrite that as H2. Mono is 1. So we don't have to write the 1. Just bring the O down. H2O. Yes, it'll be Tuesday through Thursday of next week. Yes, Tuesday through Thursday. But you know what? I will always have for the week a post in that you can go back to look at to see when I'm actually going live. So yes, it'll be Tuesday through Thursday of next week that I'll go live at this same time. But I also go live in the morning time at 10 a.m. Eastern Standard Time. Okay, yeah, come on. Come through, honey. Come through. Nitrogen. Trifluoride. Rewrite that as F3 and then N. So NF3. All right, let's see if you all can do this last one. Carbon tetrachloride. Carbon tetrachloride. Okay, what do you all get for that one? We got 22 smart students in here. I need 22 answers. 22 answers. 22 smart students. Y'all give me your answers. And don't forget to get your heart me. 22 smart students. Drop them answers in the comment box. Come on, y'all. Now there's 24 students. 24 smart students. 26 smart students. 27. Drop them answers. Okay, James put CO3Cl. You're close. You're close. Carbon is C. Tetra is 4. Chloride is Cl. Rewrite this as Cl4. bringing that C on down over here, and you get CCl4. Oh, yeah, it's all good. CCl4. All right. Bree, what you saying yes for? You didn't put an answer in the box, or did you just get it on your paper? Yeah, tetra is 4. So here, deca is 10. Oh, that's okay. That's okay. Team Mysterious, I look forward to seeing you every week now. All of y'all, I look forward to seeing coming in here. Because sometimes on Fridays, if I go live on Fridays, I consider that fun Fridays where we play games like Kahoot. And you can actually, participate by logging in and, seeing who gets on the game board. So yes, we play games on Friday. So I'll see if I might go live on Friday. I might. Don't hold me to it. It ain't on the schedule. All right. That's okay, honey. That's okay. That's why I say don't hold me to it, because that's just a maybe. Sometimes I do go live on Fridays, and that's to play games and stuff. Okay, y'all want to do one more before my General Chemistry 2 students come in here? Let me see if I can give y'all a quiz. Let's see. We're going to go to the top. Okay, I'm going to pick some random ones. Let me see if I can. No, I don't want to show y'all the answers. Okay, I'm going to pick some random ones. Hold on, y'all. Let me see. I'm going to give y'all a quiz real quick. Let me pull up one of my tests. Okay. Oh yeah, I got a test for y'all. Okay. Here's a test that we can play, or that we can do. Okay, we're just going to do a couple of these because General Chem 2 will be popping in here shortly. I'm going to zoom in so y'all can see it. Okay, I'm going to zoom in right here. And I know you all don't have the answer key. I mean, not the answer key. No, you don't have the answer key. But I will help you guys out with at least giving you the starting part. Ammonium has a +1 charge. Sulfate has a -2 charge. Calcium has a +2 charge. Nitrate has a -1 charge. So I will at least give these to you. All you have to do is match the formula, okay? Sodium +1 charge. Phosphate is PO4 with a -3 charge. Now I gave you the hint. You just need to figure out what the answers are. If you know the deal, do the swapping. So put your answers in the box. So say 1 is whatever, 2 is whatever, and 3 is whatever, okay? And then we're going to check our answers out. Okay. I'm going to give y'all 60 seconds. Okay. Okay, I see a couple of answers. All right, y'all. Let's go. Let's go. So, again, if you know they do the swapping thing, NH4 should have a 2 on the outside. Therefore, you get rid of letter D, letter C, and letter B. Your answer is letter A. Because you know that NH4 is going to take the 2 And SO4 is going to pick up the 1. So yes, A for number 1. Number 2, calcium is going to pick up the 1. So you know it's not going to be letter C nor letter D. Nitrate is going to pick up the 2 on the outside. So 2 is on the outside. So yes, letter B. Y'all are very smart in here. Y'all are very, very smart. And then number 3, sodium is going to pick up the 3. And I know y'all probably couldn't hardly see this because, because these are not, you know how Microsoft is. If it doesn't identify it, it thinks that something's wrong. So let me just do that. And my apologies for y'all not being able to see it. So for number 3, sodium picks up the 3, and there isn't a 4 as a charge. So letter D is bad. And letter C, So sodium picks up the 3. So yes, the answer is letter A. Sodium picked up that 3. Phosphate picked up the 1 on the outside. And just like that, that is your answer. So in 4 minutes, I will be having